Hello everyone, this is Chandanja and in this video I am going to discuss standard angles of trigonometry. This is the part 3 of the series Trigonometry for 9 and 10. So without any delay, let us start the video. Let us consider one equilateral triangle ABC such that length of each side is a unit. And here we have considered one median AD. So let us understand few facts about median one by one. Being an equilateral triangle, AD, this median, is also the altitude or the perpendicular of the triangle. Thus, AD will be perpendicular to BC. Point number 2, median bisects the base. So, here AD will bisect BC. Therefore, BD and CD both will be of same length, that is A by 2. Point number 3, median of an equilateral triangle, not for all triangle, median of an equilateral triangle is also an angle bisector. So here median AD is the angle bisector, that means it bisects angle A in this case. Therefore it will also be 30 degree and angle CAD will also be 30 degree. Total 60 degree because it is an equilateral triangle. So we could see that triangle ABD becomes one right angle triangle, right angle at D. Thus we can apply Pythagoras theorem here. So in triangle ABD, by Pythagoras theorem, we can write AD square plus BD square is equals to AB square. Now we can rewrite this AD square as AB square minus BD square. Thus after substituting these values of AB and BD one by one, then we shall get AD square is equals to 3A square by 4 and thus AD is equals to root 3A by 2. This is one important formula, that in an equilateral triangle, if the length of each side is A unit, then length of the median will be root 3A by 2. Now let us find out these standard angles one by one. So first of all, let us consider sine theta for this triangle. So this angle ABD, which is 60 degree, we can write sine of angle ABD is equals to, since it is opposite by hypotenuse, so AD by AB, and ABD means 60 degree and AD means root 3A by 2, thus here root 3A by 2, and AB is A unit, so here it is A unit. After simplifying, we shall get root 3A by 2A because this 2 will come to this denominator. Ultimately, sine 60 degree, that is this AA here, it will be cancelled and thus we shall get root 3 by 2. Next for sine 30 degree. So here 30 degree is angle BAD, that is BAD. So angle sine of angle BAD is again opposite here. In context of this angle, opposite is BD and hypotenuse is not going to change, that is AB, and the length of BD is A by 2 and length of AB is A. Thus we are getting 1 by 2 and BAD is 30 degree. So sine 30 degree is 1 by 2. Thus we got two standard angles. Sine 60 is root 3 by 2, sine 30 is 1 by 2. Now let us see for cos. So cos theta is known to us, that is base by hypotenuse. So cos of ABD, here in this case base is BD and hypotenuse is AB. So cos 60 degree is equals to BD means A by 2 and AB is A, thus we are getting 1 by 2. Hence cos 60 degree is 1 by 2. Next for cos 30 degree. So cos BAD, this is 30 degree. So BAD, in context of this angle, base is AD. So AD by AB, hypotenuse. Length of AD is root 3A by 2. Thus here root 3A by 2 by hypotenuse A. So ultimately we are getting root 3 by 2. So BAD is 30 degree. So we can write cos of 30 degree is root 3 by 2. So these four ratios are very important and you should learn it. In the last of this video, we shall understand that how to memorize all this ratio, we shall understand a short trick. Now let us proceed with the next ratio. So here we got these four ratios of trigonometry with its standard angles. Next is tan theta. Tan theta is known to us sin theta by cos theta, that is opposite by base. Therefore, tan 30 degree will be sin 30 by cos 30. So 1 by 2 by root 3 by 2. So this 2 will be cancelled and we shall get 1 by root 3. Similarly, tan 60 degree, that is root 3 by 2 by 1 by 2, we shall get root 3. So here two ratios of tan for 30 degree and 60 degree. Now let us proceed for 45 degree. For that we are considering one isosceles right angle triangle. Therefore, angle B is 90 and each this angle A and angle C will be of measurement 45 degree. And here we are considering length of AB and length of BC as A unit. Since it is an isosceles triangle, so therefore AB will be equal to BC. Then we can apply Pythagoras theorem here. So by applying Pythagoras theorem, we shall get AB square plus BC square equals to AC square, and we can put the values here AB and BC, and we shall get AC square as 2A square, then AC will be root 2A. So here AC is root 2A. So let us find out sine 45 degree. So sine of ACB. Sine means opposite. For angle C, opposite is A, hypotenuse is AC. So AB is A here and hypotenuse is root 2A. So ultimately sine 45 degree is 1 by root 2. Similarly, we can calculate cos 45 degree. So cos 45 degree in context of angle ACB only, base is BC, that is A unit, and hypotenuse is root 2A. So ultimately same ratio, cos 45 is also 1 by root 2. Now tan 45 is sin 45 by cos 45, because tan theta is sin theta by cos theta. Thus 1 by root 2 by 1 by root 2, and hence it is 1. So we got these three ratios for 45 degree. Now next part is very important, that what will be the values of sine and cos for 0 degree. For that, here I have drawn three circles. In the first one, you could see that I have drawn one angle theta. This yellow line indicates the radius of the circle, and this green line indicates the perpendicular drawn from this point to the x-axis. Now, if we reduce this angle theta, how will it affect the perpendicular? Let us see. Here, theta is quite bigger. Now, if we reduce this theta, then our radius will come downwards, and thus the length of the perpendicular will be like this. So we could see here the length of this green line and here the length of this green line. These green lines are the perpendiculars drawn from this point, that is point of intersection of the circle and this radius to the x-axis. Now if we further reduce this angle theta, here theta was more, here it little less, and further we are decreasing it, then we could see the length of the green line, how it is being affected. Now if we further reduce it, then we could see this green line has been reduced a lot. Now if we bring it to 0 degree, because gradually we were decreasing the angle theta, the angle between this radius and this x-axis. Now we have brought it to the x-axis. That means here in this case, angle between the x-axis and the hypotenuse, that is yellow line, is 0. Then we shall get height or the perpendicular green line. That means there is no green line, that means the length of this green line is 0. So height or perpendicular also becomes 0. Why? Because hypotenuse is coinciding with x-axis. Thus, sine theta is perpendicular or hypotenuse by 0. Thus by perpendicular opposite by hypotenuse. So Perpendicular here is green line, no green line, that means 0 by length of yellow line, that is hypotenuse here. So sine 0 is 0. Now one relation is known to us, that cos 90 minus theta is sine theta. If we put theta is equals to 0 here, then we shall get cos 90 minus 0 equals to sine 0. If we put theta equals to 0, because theta is 0 in this case, thus cos 90 degree is equals to sine 0 degree. No doubt they are complementary. Thus sine 0 is 0, so cos 90 will also be 0. Thus we are getting these two important ratios. So sine 0 is 0, but cos 90 is also 0. Next, for cos 0 degree, let us understand. So the hypotenuse coincide with x-axis. Thus base and hypotenuse will also coincide. Here no perpendicular, no height is there, but hypotenuse and this x-axis coinciding, therefore hypotenuse and base is coinciding, therefore base is equals to hypotenuse. Now cos theta is base by hypotenuse. So since these two lengths are equal, so here we can write hypotenuse by hypotenuse, and cos 0 degree is 1. Now this relation is known to us, sine 90 minus theta is equals to cos theta. Again, if we put theta equals to 0 degree, then we shall get 90 minus 0 is equals to cos 0. Thus sine 90 is equals to cos 0, and cos 0 is 1. So sine 90 is 1. So we are getting cos 0 degree is equals to 1 and sine 90 degree is equals to 1. And in previous case we got cos 90 was 0 and sine 0 was 0. But here cos 0 is 1 and sine 90 is 1. So let us form this table. This is very important and you should learn it. So let us put the values one by one. So sine 0 degree we got 0. Sine 30 degree we got 1 by 2. Sine 45 degree 1 by root 2. And sine 60 degree root 3 by 2. And sine 90 just now we have seen, that is 1. So let me tell you, we only have to memorize this sine part. Once you will get this row, you can easily form this table. So we only have to memorize these values of sine 0, 30, 45, 60 and 90, because rest of the values are interrelated to sine. Let us see how. We know that sine and cos are complementary. So here 0 degree, 0 is complementary to 90 degree. So whatever will be the value of sine 90, that will be the value of cos 0. In short, I mean to say that the arrangement that we have done from left to right for sine, same thing we shall do for cos, but from right to left. So cos 0 is 1, that we have already seen, we have calculated. Cos 30 is root 3 by 2, we got that. Cos 45, same sine and cos will have the same value, and cos 60 degrees 1 by 2, and cos 90 degree we have seen, that is 0. So you could see that sine, whatever the values are there from left to right, cos theta is just the same values but arranged from right to left of this value. So that is why I said you only have to memorize this sine, because rest of the ratios are interrelated. You can easily form the table if you remember these 5 ratios. Next, for tan theta. So sin theta by cos theta is tan theta. So 0 by 1, 0. 1 by 2 by root 3 by 2. So 1 by root 3. These two values are 1, and here root 3 by 2 by 1 by 2. So ultimately we shall get root 3, and here 1 by 0. Now let us understand here. 1 by 0, sin theta by cos theta. Here in the denominator it is 0. We know that we cannot divide anything by 0. any real number by 0. Therefore, this one is undefined. Now, for cosec, that is the reciprocal of sine. So we can get these values because that is the reciprocal of sine. So 1 by 0 again undefined, but 1 by 2 will become 2, and here root 2, here just reciprocal of it. So 2 by root 3 and 1 by 1 will remain 1. So similarly, sec is reciprocal of cos. So these values, and cot is reciprocal of tan, then we can get these values. So that is why it is important to remember these 5 ratios. Now if we forget these 5 ratios also, then also we have a simple trick for it. Now let us understand how. This 0 is 0 by 4, square root of that. 30 degree, for 30 degree we can write 1 by 4 and square root of that. For 45 degree, square root of 2 by 4, you could see square root of 2 by 4 will become 1 by root 2. And for 60 degree, square root of 3 by 4, that is root 3 by 2. And for 90 degree, square root of 4 by 4. So if you forget these 5 ratios also of sine, then we could simply memorize this trick, that the value of sine from 0 degree to 90 degree will be square root of 0 by 4, square root of 1 by 4, square root of 2 by 4, square root of 3 by 4, square root of 4 by 4. But this trick is applicable only for sine, not for other ratios. Please remember, you only have to memorize these 5 ratios, and rest of the ratios are interrelated. You can easily form the table if you know these 5 values. That's it. Now let us come to the questions of previous video. So the answer for the first one is 1. Answer for the next one is root 3 by 2. This one was very easy because sine A and here equilateral triangle was given. So sine 60 degree root 3 by 2. Today we got that value. And this one, if you need the explanation, please write it in the comment section. That's all for this video. Thank you for watching. Thanks a lot.